Hey everyone, how's it going? Happy Thursday. We're going to be focusing on our PyTorch expert journey. Today we're going to be doing kind of I'm surprised that how far in this tutorial we are and how easy this tutorial is. We're going to have an easy day today. It's going to be easy day. Super simple, super easy. Easy day today. Training with AI. Oh, Torva, hello. Hey, welcome on in. Good to see you. You made it here like instantaneously. I think that's like a new record. A new instant in. Good to see you. Good to see you, Torva. All right. Oh, Sigma Edits, how's it going? Hello. Soki, what's up? Hey, you guys. Good to see you. Welcome on in. Happy Thursday. We're going to have an easy day today. Easy day. We're going to go through the next part of our PyTorch tutorial journeys. We have this training model section, which is training with PyTorch. We're going to train an AI. And this is a convolutional neural network. Really easy. We've actually done this like 3 or 4 times already on stream. However, we're going to find out. We're going to find out if there's anything crazy or new that we're going to learn. There always usually is like 1 or 2 tidbits in there. So we're going to find out. Hey, hey, the Dreamer. Welcome on in. I almost called you Claude. My brain auto-translated it to Claude. In past videos, we've discussed about building models and neural network layers, functions of the Torch neural network module, the mechanics of automated gradient computation, which is central to gradient-based model training, isn't that what everything is? Isn't that all the things? It's always like that. You need to finish your seminar tomorrow. Oh, soft actor critic. About halfway done, you don't have the motivation. Oh no! Hey, it's okay. You have so much time left in life. You'll have no time. Although it's probably due pretty soon, right? Yeah, I got now set up with when you stream, it automatically opens up the notification oh, no way. If you're not in disturb mode. That's really neat. I didn't know you could do that. Seriously? It's Saturday? Wait, what do you mean Saturday? Oh, dude, it's due Saturday. Oh, okay. Well, you only have a couple days then. You don't have much time. Mobile user experience of YouTube live streaming and comment is not that good. Really? Oh, well, I think it's okay. It's not can it be better? Who knows? Who knows? It's currently technically pretty good. However, could it be better? Could it be better? I think so. Using TensorBoard. Yeah, we used TensorBoard over the last few days. I'm okay with TensorBoard. It's fine. I don't know if it's like my favorite thing. It was neat. However, I think I'd just rather visualize everything directly in the terminal. Wouldn't you? I want to keep everything in my terminal window. Right here. Keep it all directly in the terminal window. Let's see, is that? Let me move this into the proper location. Where is that here? Hold on. Let me move that. Where is that at here? I'm trying to align this because I accidentally moved it out of the way. There we go. Okay. Soki, what are we training today? We're going to be doing a convolutional neural network, and I believe it's just some clothing pictures again. We've done this before. It's going to be an easy day. We're going to sit back. We're going to see if we run into anything that we haven't seen before. Apparently, it's new in the tutorial. It's new. It's like really late in the tutorial. It's like second to last, and I believe we've covered all the tutorials at that point. I think we've covered everything. Can you walk us through the process of choosing the right layers and number of neurons? I think that's kind of hard to estimate. It is. What you want is the minimum. You want the absolute minimum that you can get in order to achieve good results. Because otherwise you're just throwing away data and compute. You're wasting compute. You can make the numbers really big and get really good results, but at a cost of very slow training and lots of compute waste. So, Soki, the answer is the minimum. You were seeking the minimum. You want it little. Seems like Safar. Well, so there are different kinds of layers because you've got projections or filters, and then you've got connected layers, where it is fully connected. And with transformers, you've got 3 filters, right? You've got query, key, and value, QKV. And convolutional neural networks, you have a dynamic number of filters. And you could have like hundreds of filters. And you want to do that for edge detection because you're going to do a max pool to find the highest value to detect the edges. Oh, the Saphir 10 problem. Oh, let me see here. Let me see. Is that an image problem? Let's look this up really quick. Oh, okay, yeah, okay. So that's just a bunch of pictures, and it's a classification problem. So you just do standard CNN. You're actually do what we're going to do today. You're going to do exactly what we're going to do today, and it's actually not that challenging. All right, you bring up a good point. All right, the Saphir 10 problem. It involves 60,000 images, 32 by 32 pixels, 10 distinct classes: airplane, automobile, bird, cat, dog. We're doing the same thing. We've got 10 classes, and we're going to do clothing items, so it's essentially the same thing. We're going to do that today, Soki. That's the plan for today. Meet you on Monday. Sounds good, Dreamer. Second like. Oh, the Dreamer, thank you. I see your message there. Tag in desktop gives you suggestions to tag when you are starting to write your name. Oh, nice. All right. Good to know. Dreamer, thank you. All right, you guys. Zergio. Hey, Zergio. Thank you for the donation yesterday. I remember that was great. You added some things to your project from your Rust stream yesterday. Oh, isn't that was a good one, right? I thought that was great. Thank you so much more. I still have to learn. Rust is fantastic. Rust is fantastic. All right, so today we're going to go through CNN, convolutional neural networks. We've been doing this multiple times on stream already. It's just a repeat for the most part. However, we might learn something new. You never know. You never really understood pooling? Pooling's really easy. It sounds really advanced, doesn't it? It sounds like it's super amazing. It sounds amazing. It's not as amazing as it is. We'll walk it through. We'll walk it through you. Downsampling a picture so you look at different resolutions. It is sort of. It's like looking at outlines is what the idea is. How's it going there, Cammy? Welcome on in. Good to see you. Thanks and hello. Mark Lemon. What's up, buddy? Thank you for clicking the hi button. Welcome on in. Happy Thursday. All right, Soki, check this out. Max pooling is really easy. It's really easy. So I've got it around here somewhere. Here, I'm just going to see max pooling. Do I have it around here somewhere? There we go. Okay. So we've got a picture of a cat here. And then say we've got a bunch of numbers. See like these numbers here? We'll zoom in a little bit more. We got some numbers here. All right, check this out. So we'll do a max pooling where we focus on just capturing. So it's a window of 2, a stride of 2. So here, we'll do a max pool over this. So you see we're looking at 4 numbers. And what the max pool 2-dimensional does, how's it going there? Shia, welcome on in. Jefferson, hello. Good to see you. Welcome on in. Happy Thursday. All right, Soki, so this is max pool. Let me get this going here, number 8. Let me type 8 here. This will be max pool 2D. Really easy, really easy, really easy, okay? So that means that we're going to be looking at all of these values here, okay? And we're gonna look at 4 at a time, right? These 4, and they're all like next to each other in a 2D grid, right? In 2D grid, so there's proximity to each other. The max pool basically says, what's the max value? And then it takes that max value. So it basically divides the total resolution of the picture by 4, but it looks for the biggest value. That's it. That's all it does. Isn't that amazing? Isn't that crazy? You thought it was something more, you thought it was something crazier. It's not, it's not. How's it going there, Dharma? Dharma Squad, welcome on in. Good to see ya. I saw your message there. Where can I learn AI from basics? Kemi, that's what we're gonna do today. We're gonna go through a full basic introduction tutorial on a convolutional neural network. By the end of the stream, we'll get most of the way through it. We might have, to resume it tomorrow, depending if we make our way. Yeah, if the YouTube notification doesn't glitch out, it works. It basically is just a macro that filters your notifications in the action center for your channel plus the live. Torva, that's magic. You got some magic there, Torva. Are we going to do edge detection? Yes, from scratch. Well, not from scratch. I mean, although you're just looking at it right now. Hey, Loons, I saw your message over there. I'm trying. I got it. I see it. I saw your message over there. Good to see you, Loons. So edge detection, yes, that's basically what this is. It's just running this max 2. It doesn't need to be from scratch because it's such a simple algorithm. You're just looping over nearby pixels and picking the largest value. That's all you're doing. It sounds like it should be even more. No! Hey, Neva! Good to see ya! Are you Stevening? We are Stevening. We are Stevening. We figured it all out. We figured it out. Soki was curious about max pooling. And I'm like, it sounds like it's amazing. It's actually pretty straightforward. But you can also like choose the step to filter, right? Yes, if you want, yes. So if you want to do a step of 1, then you'll step in and do step 1, which means that you're going to grab these 4 values and you're going to pull a value out, which would be 4. And then you're going to do a step again and you pull out 5, right? 0.5. And then you'll step down over here and pull again, step of 1, step 1. Or you could do a step of 2 where you look at this one and you look at these 4, right? So you bob between these 4. So the default, I think, is mostly a step of 2. For edges, using a sharp filter with SME negatives, and the pooling works very well. There you go. Get those edges in. It's kind of ridiculous how good a result you get from just these 2 filters. It's pretty surprising. Also, oh, hey Kyle, good to see you. I just saw you said hello over there to Neva. Welcome on in. Happy Thursday. There was this kind of trick to choose a filter size of 1 by 1 instead of, so I think that's the window size or the kernel size. You want, I think, what is it? 3 by 3 is the best. Universally best. Right, 3 by 3. I think that was kind of, like if you went bigger, it had diminishing returns or it didn't help at all. So I think that was, I remember watching that in a video somewhere, some time ago. Although, feel free to experiment. Try out different kernel sizes. Try them out. Try them out. I think 3 by 3 is the universally best, though. Okay, so let's go into our tutorial, you guys. Oh, I wanted this tab. Okay. What are the different layers available? We've got identity, a placeholder identity operator with argument insensitive. What is that? I'm familiar with linear. What is bilinear? Applies a bilinear transformation to the incoming data. Huh, what, the more you know, huh? Applies a linear transformation to the incoming data. So it looks like that. Oh, lazy linear, a module where in features is inferred. What? What does that mean? Do the outline usually have higher weights? Yes, because, well, the output from your inputs is going to be higher because they're larger values, because you're looking for the largest value in the set of... Hello, what's up? So we're doing a ResNet today. Or yeah, kind of like a ResNet. Yeah, not a full-blown ResNet. Bilinear is super linear. Is a lie? It's just extra linear. Okay. It's a really... It does even more. Bilinear for like images, right? Or something? I actually don't know. I've only ever used a linear layer. I didn't know that there were other kinds of linear layers. I didn't know. I had no idea. Ooh, we want to do transformers. So this is going to be a stream that's going to come up here. We're going to do a transformer here. That'll be something we do later. Recurrent layers. So we messed around with most of these. We did an LSTM. We did RNN. I'm not familiar with these other ones, though. I don't know what these things are. A long short-term memory cell? So it's just like a smidgen of it? Is that what that means? It's a smidgen of LSTM? And well, this one is a full multi-layer long-term. To an input sequence. Okay. It likes 3 dimensions. I remember that. It likes 3 dimensions. OTS, a funny name because what they show is actually a quadratic map, not just bilinear. For this bilinear here, take a look here. Applies bilinear transformation to the incoming data set. Wait, why are there two inputs? What does this mean? A size of each of the... Oh, wait. No, it's supposed to be in and out. Hold on. Wait. Let's look at this one as well. Yeah, oh, interesting. So there's 2... That's weird. Look at this. You need 2 sets of features in. Huh. Interesting. I didn't know you could do that. When would you want that? In classical machine learning, you can scale data before doing... Yes. You need to normalize or vectorize the data, right? You want the numbers on the input side, standard scalar, have to be shrunk between 0 and 1, right? That's what you got to do. Can you look at general? General, please. Okay, Loons. Yes. So Soki, yes. You want to make sure that when you're inputting data into your model right here, so you have these feature inputs right here, you want those numbers to be between 0 and 1. So you want to scale it. Oh no, never mind. Yes, bilinear is the bilinear. Didn't see the second input. I know, right? I was like, what's going on? Oh, we've got some new math here. Hey, Quantified Quantum, good to see you. Welcome on in. Happy Thursday. We're going to take a look at general here. 3 ads? What? What do you mean? What? Loons, what? 3 ads? You saw ads? Where'd you see those? Is that what you're saying? Quantified Quantum, good to see you. All right, you guys. So what we're going to do today is we're going to walk through this tutorial, this new ConfNet tutorial that we haven't seen before. It is at the end of our journey, for the most part. It's the end of our journey. When you click from Discord, you get ads. Oh, really? No way! I didn't know. Bilinear maps are actually somewhat common if you think about attention layers in those terms. It's not so different. Okay. All right. Well, we're going to be learning some transformers later on here. Sorry, memes. Memes? Oh, memes. All right. All right. This literally translates to account created the yesterday. Oh, a very good translation. Yeah, no. Account created the yesterday. Le hair. Compte crée le hair. Account created the yesterday. The le is the. All right, we'll be getting familiar with data sets. We already know this part. We already know data sets and data loaders. We know about those perfectly fine. We know how to use the transforms, which is actually really nice, by the way. I like those transforms. However, if you're really being serious about a production grade AI application that you're building and you want to get things really ready, your data loader is doing a bunch of work that you are repeating and wasting, essentially. Although there might be scenarios where you want to treat the data differently, I understand. For the most part, data preparation is pretty static. Once you've loaded in your images, you want to transform them once, store them in maybe a vector store or just flat files, and then load them in separately afterwards, so you don't have to waste a whole bunch of compute transforming things. Steven, what's your view on foldables in general, like foldable phones? I am fine not having one. I think I run into enough situations where I'm just trying to get my regular phone to turn on, where I'm like, wake up phone. If I have to also open it up and then, get action going, I feel like that's extra effort. Because I might be like, you guys might be like me, where I pick up my phone and put it down a lot. So I need that interaction, because I do that so often, to be optimal. Yo. Did you know you can direct message people? Yes. Saw you message here. That was neat. Thank you for showing. All right. Honestly, one of the biggest things with PyTorch is that they don't force you to use the data loader, so you can optimize things better. Yes. So you know what? Right before I was starting stream, I'm like, I don't want to use the data loader. I don't want to use the data loader. I just don't. I want to do my own thing. And you're right. You can bring your own thing. You don't have to use the PyTorch data loaders. You don't. Can you use deepfake? Yes. Soki, absolutely. How's it going there, gents? Good to see you. Welcome on in. Hi. The EU just passed the battery law, right? You can use, what's the battery law? Hey, Steven, hope you are having a great day. I am. And Schumann. Good to see you. Welcome on in. Happy Thursday. We'll discuss specific loss functions when we use them. We'll take a look at the PyTorch optimizers, which implement algorithms to adjust the weights of the model based on the outcomes of the loss function. Yep, we know all about that. I think we're getting pretty good at this now. Finally, we'll put all those things together to see a full PyTorch training loop in action. End to end, everything is going to be covered. This is a full coverage. By 2027, every phone needs to have a swappable battery. Got it. Right. So the iPhone, it kind of has a swappable battery. You need to send it in to Apple to usually swap it, or you could hire someone to do it, or it's a lot of work, right? It's a lot of work to have to deal with. All right, you guys, let's get into it. Datasets and data loader classes encapsulate the process of pulling your data in from storage, which is usually a hard drive, right? Hard disk drive, solid state drive, exposing it to your training loop in batches, which is the nice thing. I do like that with data loaders. They are very, very nice because they will shuffle your data because you want to randomize the data when you're training. And they will also pull in batches from that shuffle, which is nice because that's a lot of extra, work that you don't normally have to deal with. That's one that I think that's, and then the automatic transformations. Don't get me wrong, they're nice things to deal with. It just mostly, I'm not motivated to do it. When you enter your stream, the first thing that I do is like the stream. Oh, and Schumann, thank you. Thank you for clicking the like button and the hearts, you guys. I see those floaty heart icons there. Thank you, Anshuman. For Android, you kind of just take R8 the thing out, maybe a bit of tapping around it. Yeah, for the most part, I think so. Yeah, that's what I do. How's it going there? Deckerfer, good to see you. Hi, Better and Better Dan. Oh yeah, hey, Better and Better Dan, good to see you. Welcome on in. Those hearts usually you for feeling guilty and distracting me. Oh, please keep clicking those buttons. Click the heart button as much as you possibly can. We're trying to teach the world about AI. Let's teach the world about AI and how to use it. You think TensorBoard is kind of a pain to use? It is. I know. We were using it the other day. I'm like, I mostly want to keep all of my output, directly in my terminal. I like it right here. I like it all right here in my terminal window. And I can visualize it in real time without having to wait. Let's distract Steven. Exactly. You can distract me. That's why we guys are here. If you weren't here, then I wouldn't be live streaming. I'd be doing something else. And Schumann, what does it mean to access and process a single unit of data? It depends on how far you break it down. Oh yeah, don't forget the Discord. Yep, I forgot about that. So single unit of data probably in this case is going to be like one picture. So this is like a shoe, right? So this might count as one unit. Though if you're thinking of units, you're probably talking about a parameter or a weight or coefficient, which is just a number. It's just a single number. What does that number look like? It looks like this right here. So you might have like a number, and that number is one of your parameters. It sure is. What is a unit of data? Like samples? Maybe like a megabyte? Exactly. It depends on your scope. What are you looking at? Can't we do a multi-process kind of approach? That's what we do. That's what we do. Look at all these numbers. There are too many numbers there. So we need to multi-process it. You got it. You got to multi-process it. Which we're going to do. We're going to be using GPU accelerators, you guys. Okay. So dataset is responsible for accessing and processing a single instance of data. That is going to be a picture in this case. One photograph. The data loader pulls in that instance automatically with the sample that you've defined. It collects them in batches and returns them for your training loop. The data loader works with all kinds of data sets. Doesn't matter what it is. It could be anything. How's it going there, Jeff? Good to see you, Jeff YouTube. Welcome on in to device. Yes, exactly. You got it. I think you can just use .2. You don't have to say... So you go like this. Let's see how. Where's terminal? All right. Vi. Let's see. Full CNN.py. Import torch. We can say torch.tensor, and we say we're going to build like a tensor. Then we'll just a vector. We'll say a equals print a, and then we can say a.2, and we have a device, and we have accelerators dot current accelerator. This will be our device. I think that works, right? Let's find out. Python full CNN. There we go. Oh wait, I forgot to print it out. Let's see here. Did I type the right? Accelerators? Did I spell that correctly? Torch has no accelerators. Doesn't it? I feel like I'm typing that wrong. What do you do for a living? Oh, Tutor Royal. Hey, good to see you. JM, welcome on in. What's up, dude? Hey, I was going there. Zero Null, welcome on in. Multiprocessing's kind of I like the MP, right? Separate memory spaces, threads. Yeah, I like multiprocessing and queue, so message passing. That's the way to do it. Tutor Royal, what do I do for a living? I've got my own business. Threads aren't good as well in Python due to GIL. Yeah, threads, you don't want to use threads for multiprocessing because it won't distribute your workload across multiple cores. You want to use something called multiprocessing MP, which is a Python library that's going to fork or essentially create new processes on the operating system, and you'll be able to pass work between your main worker and all the children worker, or all like the sub workers, through message passing or queuing. Usually like an IPS type of thing. Torch.device. Is it device? Is that right? I feel like I'm missing something. Let's do this. Watch Python import torch. Hi chat. Good to see you guys. Welcome on in. Thanks for the warm welcome. Yeah, absolutely. Bro edits text files for a living. You got it. That's right. You got it. My own business here. Stephen Blum, CTO, PubNub. We raised 134 million, Series E, billion devices on my network. We do communication for mobile apps. You've got apps that do all sorts of things here. So many different things. Transportation, gaming. You've got, what else we got? Sports media, multiplayer games, you guys. So I started this company a long time ago with my co-founder, Todd Green, CEO of PubNub. Threads in Rust are a heaven, right? Yeah, they're so much better in Rust. Yeah, you're right. They're so good. Oh, thank you for Beast Views. Thank you, Beast Views, for the subscription. Welcome on in. Good to have you here. Happy Thursday. You joined the right channel for software engineering. We focus on this channel building software, mostly AI right now. So we'll be doing some AI today. Python's not great for parallelism. It works okay if you're using MP, multiprocessing. The best options. Yeah. Wow, Stephen, amazing. Yeah, Jeff, thank you. Yeah, we do this. This is my business. We've been around for 14 years, and we have a lot of patents, and we're distributed globally, so you connect to the closest data center across all of Amazon's availabilities. Python executes a single byte of code at a time. Yep, it sure does. I do follow you on LinkedIn, or yes, absolutely. That sounds great. LinkedIn, there you go. We got LinkedIn here. How do you have time while being a CTO? I'm a digital forensics analyst, and I barely have time. Well, what I'm doing is what I do on stream is focus on things that I would be doing off stream anyway. So you got to multitask, right? You got to multitask. The goal is to become a PyTorch expert, you guys. How do follow you on LinkedIn? Well, I mean, if you just go to here, I'll put it in our Discord. I'll put it in our Discord here under link share. Link share. Here we go. And then you can click into it. Click right over there. Okay. Let's see here. Multiprocessing is the best option. It's still, yeah, you can make it okay if you use the queue, if you use queues. It's not great, but it's also pretty good. It puts everything in a CO memory, and it's really annoying and potentially a problem on Windows. Oh, I didn't know. I've always used it on Linux. Kind of requires work for fork, which Windows does not have. Yep, I've always used it in Linux. Do you think we need to be awesome in math to actually excel in PyTorch? I think math is, if you're gonna, in any computer science, the only place that you really need math is multiplayer gaming, just gaming in general, and AI. Those are the places where math will actually help you a little bit. You need a little bit of math there. When you're doing everything else though, even aggregation, data science, big data, you don't necessarily need that much math. You need basic math at that point. For AI though, AI is the most math intensive. All right, import torch.excel. Here we go. Let's do dir. And can we do, let's see here. Accelerator. There, it's called accelerator right there. It's right there. Here we go. And then we do dir on dot accelerator. And then we got current accelerator right here. See? We're figuring it out. Thank you for the hearts, you guys. Appreciate it. Do you have a GitHub account? Sure do. All right. GitHub account right here. Pin this. Here we go. Here's our GitHub. Right here, you guys. We got our GitHub. Right here. Have you seen Google Flow commercial? I've used Google Flow. I've used it. It's pretty good. It's pretty good. Thank you for all the hundreds, you guys. Good to have you here. Happy Thursday. Most AI papers you read back in the day were much more complex math than anything you studied so far in college. And I'm towards the end of your degree. Oh, yeah. It's a little, right? It's the most math. AI is the most math you can have. You're going to be mathing a lot these days, trying some kind of PhD expert. That sounds pretty good. Ed, thank you for the shout out. Thank you. Basically, though, what things to work on in the model doesn't perform. It's, yeah, not as good in basic maths. But if you're doing some gradient descent on the job, you should understand the basics, though. Yeah, that's nice. Real-time, yeah, exactly. Real-time two-way JSON running on Amazon EC2. Why don't you try it? It's free. Those lyrics are made. I know, they're pretty good. Yeah, that was a little while ago now. It was like 15 years ago or so. AI math is these really nasty integrals, which are a nightmarish. Yeah, AI is going to be the roughest in math, you guys. It's the most rough. All right, so let's see. AI.2 divide. Does this mutate? Let's try this. Full. That is. Let's try this. Do we have to mutate it? Yes, we do. Okay. So we have to shadow the data. Okay. So now you can see, I forgot what we were doing because I got all distracted, but we can, so you don't need to say .2 device, you just say .2 like this. It's a little function right there, and it automatically understands what you mean when you run 2. So you can move this over to your GPU accelerator. .2 does not mutate, it duplicates. Yep. Yeah, we just found that out. And always got to test it. Any advice into Excel and computer vision? I recommend looking at state-of-the-art vision transformer. Take a look at these. What's up, Mr. Blum? Dylan, welcome on in. Dylan 1.2, good to see you. Happy Thursday. We're going to be doing some PyTorch, you guys. All right. Let's see here. For this tutorial, we'll be using the fashion image dataset, an easy one. We use torch vision normalize to center the zeros and normalize the distribution of the image content. So all the pixels. There's a lot of data in these images that we can sort of compress and reduce because many colors in these images don't even get used. So it's a giant color space, right? It's 256 or 255 times, 256 times 256. So it's a lot. It's a lot of color combinations. So we can delete most of them by normalizing. July 14th, 14 years. There you go, 14 years. It's a long time. Yes, vision transformers. Yep, there you go. Kind neat. We're having a CV this semester. Thank you guys for the reactions. It's kind of tough to understand all these filters. There's a lot of things we're going to walk through here. There'll be a lot of things here. Shivam? Bro, I've just joined your chat, but I need help. In landing a job, advice, tools, learn the things you study and growth. So a big part of the interview when you're interviewing is going to be that relationship or that introduction to you as, your style of collaboration. And if you match the style of collaboration with your interviewer, you're going to have the best time, your highest chance of success. There is and it's okay if you don't know things. It's okay. What you want to do is figure that out. Usually in interviews, what they do, check this out. They don't ask you a question of something that you probably know. If the really good interviews ask you questions for problems that you've never solved before, And then what you're supposed to do is work together collaboratively with them to solve it. That's what a real good interview would be. And really in that process, it's not about your knowledge or whether you succeed. It's how you spend your time with the interviewer. Isn't that neat? That's how it works. This is something that not everyone takes attention to. Vision transformers are the death of CNNs. Well, you got the new vision transformers. Got my PowerShell scripts working yesterday. Hey, Daniel Hart, all right. Was so amped that it did the things it was supposed to do. Good logging too, nice. Daniel Hart, get those PowerShell scripts working. These days it's okay to say, well, right now, at this point, I'll just ask ChatGPT like specific functions because I don't remember it. I know. Yep, that's one. It's like, why don't we just talk to the AI? I mean, you got to be careful in an interview to say that's your solution because you're supposed to work together collaboratively with the interviewer. Or you'll do the interviews, still want to hear, I'm going to read the docs. Yeah, most of the time you're supposed to, here's the deal. When you're at work on a job, most of your day job, you're not going to know really how to solve something. You are going to go search to learn how to solve something. That's what your job is. You need to go seek out what it is that you need to solve, the information that you need. You won't know it. You won't. That's one of the things. Why don't you just get the magic lamp, roll some dice and flip a coin? That's it's RNG. It is, Kyle. It's RNG. All right, let's go through this tutorial, you guys. Let's start typing this stuff in. So we're going to do vision, torch vision with transforms, which just allows us to mutate the data into a shape that is going to prepare it for the input on our model, because we want to get those numbers between 0 and 1, right? Get those numbers between 0 and 1. At this point, the job market after school, I'm going to pray. Hey, good news. It's increasing. Job market is increasing. It would just be as good as anything you did so far. I think you're going to be good. It would be better if you waited another year or two. I'm still amazed that the MP3 and OG downloads of the music are still available. Are they really? Wait. Hold on. All right. Here's the music. More. Oh, right there. Look at that. Go to site. It's there. Look at that. Those have been there for a while. You can find, if you look at the metadata on those MP3s. That's really neat. Loons, you clicked a button that is magical. Bro, that's some good advice. Your refresher of the interview is not collab. They just want the answer straight. Oh, then that's a red flag. That's a red flag. If they're asking you for that and they don't want to be collaborative with you, they are someone you don't want to work for. Yeah, you just gotta be careful. It's a two-way street. You're interviewing them too. So what you need to do if you want to, if you really want to push through and you want to work there anyway, and you're sort of steamwalled by someone who doesn't really want to collaborate with you, you need to use soft skills to get them into collaborative mode. Right? You gotta say, hey, let's figure this out together. It'll be a lot of fun, right? You gotta like entice them. Have you ever modified open source Python module and fixing limitations and apply it to your local code? Yes. Many times. I have. Any technology that I should learn? My recommendation is Python, SQL, JavaScript, TypeScript, and AI. Those are my recommendations. Hey Aziz, good to see you. Yo, Steven, why don't you do a challenge, built a full app in 24 hours and vibe code, of course. Oh, well, we are going to have a hackathon. It's coming up here in a couple weeks. I'll drop the details in Discord. Ask your AI for a blessing before each prompt. It works. Trust me, bro. All right, there you go. You gotta coax the AI to give you the details that you're looking for. I need it to be written successfully, so you have to bless the AI. Well, I would recommend you just say you had cross-reference. Since you're not sure, basically use your knowledge of agnostics and what the function is doing to assume its parameters. Torva, You're saying some fancy stuff there. So you present them with what you have a grasp of and what you need on how it works. You are unsure, but it's specifically what it needs. Yeah. Usually that's the case. That's usually the case. So you just need to work collaboratively with them in that session, in that interview session, to solve the problem. Isn't that great, you guys? It's real. It's real. Look at the Discord. Metadatas are deleted. What does that mean? What is metadatas are deleted? New plan. We pray to the AI. Yeah, and hope that it works. That's the way to do it. Sorry, catching up with your chats here, you guys. You got a lot of chats today. Security analyst, quick question. Do you follow security coding practices by default while coding? Yes. All the time. Yep. Always. Security first. Very important. How does software development work? Like, well, today you asked the AI to write the code for you. That's what you do today. That is exactly what you do today. Yo, Hackathon, want to participate? Where's the prize? Yep. Is there a prize? Yes, there is. We'll have like a cash prize, I think. Can we join the hackathon? Yes. We'll put it in the Discord over here. Metadatas are deleted. Oh, well. Interesting. It's like they're rewritten. They got rewritten. Loons. Okay, I got you now. I understand. Yeah. Okay. Well. Oh well. I guess not. What you got the OOG? What about the MP3? Check the MP3. At least you want to save tokens. Got to save those tokens. All right, general. Got 3 ads. That's crazy. I didn't know that was going to happen. See how. All right, see if I can catch up with you guys here. Hackathon, yes, you could join the hackathon. Software is very diverse. There is no one way on how to develop it. Yeah, exactly. Modern software engineering, you'll use some sort of stack probably, and then you integrate it with a team and you'll have a database probably. Depends on what you're building. It really does. Looking at the MP3, nice. Software is so diverse. Did you hear Facebook bought Modbus in 2025? And now China government says it wants it back? It can do that? China can do that? I mean, I guess they could say it, but are they going to steal it? For example, PubNub is a web company, so they don't use any unsafe in their Rust. Yes, exactly. This is very different from something which is like a game running locally trying to use a bunch of SIMD. Yes. Does doing self-projects count as experience or job necessary? No, it does not count as experience. It still counts. It counts. And you want to use that knowledge that you've gained during your exercises and building projects in your real world applications. So it counts. It's not a replacement for on-the-job experience. Manus. Okay, Manus. Yes. Running difficulty keeping up with the chats, you guys. This is so great. Y'all chatting today. Steven, can you give us the Discord link? Yes, Aziz. Oh, Torva just gave it to you. Thank you, Torva. All right, party popper. All right, good to have you guys here. So based on the use case of the function, you assume its parameters and present your line of thought based on the general system language, but not knowing its concrete parameters needed. Hello, it's nice to see you, always hyped up and happy. Oh, Razili, good to see ya. Bit of fresh air. Good to hear it. I like that. That's so nice of you to say. All right, you guys. Steven, let's see. All right, okay. Soki, I mean, not really into web dev so much, but full into DS. So PyTorch sidekick. Oh, data structures. Got it. Same with the MP3. Oh, no. Well, thank you for checking. Appreciate it. Thank you for checking that. So PyTorch, yeah. So then, Soki, you're on a good path then. You are. Data science, exactly, prod by core. Exactly, data science. Let me see here. All right, you guys, let's get back to the tutorial. So let's write some of this code out. Yeah, data science, there we go. That's what we're doing today too. That's what AI is, you guys. data science. All right, so we've got our device. We're going to keep that around. We like that. We like our device. Import torch vision, and we're going to import from torch as transform. Okay, transform as plural as transforms. Okay, we're going to keep that around. So we get our device there. Sorry to disturb you with these questions. You're just stuck and thought you could help me out. Oh, sure. Let's see. Shiva, let me double check that I found your message here. You have built some websites using Claude. Okay, I missed your message. Thank you for mentioning it. You know how to use AI to help you out, but we cannot tell, yeah, I used AI to help me out, and then when errors occur, most of they are solved by AI itself. You're in the modern world of software engineering. What can I say? You're in the modern world now. You're absolutely in the modern world of software engineering. Let's see here. Do that. I think, is that, where are we at here? Yes, okay, good. Okay, party time. There we go. All right, so yes is the answer. Yes is absolutely the answer. Let me go back to it. I'm gonna double check that I actually got it right. So AI is fine. Though, I mean, it really depends on your role. So most of the time, it's, people can use AI to solve what they're gonna need. They're gonna use AI. In fact, I do all the time. I do it all the time. Okay, you guys, let's get back into it. Hopefully you're gonna land your ML engineer job just in a few years. Oh, good timing. Yes, it's gonna get better in a few years. PhD is his bachelor degree. Nice. Working on your software in OpenGL render? No way, OpenGL? That's crazy. Link share? Okay. PS1 EMU. Ah, there you go. OpenGL for PS1 EMU. Nice. OpenGL is such an interesting tech. I remember I used it many years ago. OpenGL is really old. Is still supported? I guess so. Who would have thought? How many cups of coffee is normal for a dev? I changed to 0. I changed to 0 coffee. And I feel amazing. Super unsafe though, like all the stuff around the raw pointers between GPU and CPU. Yeah, that makes sense. Good night from Poltergirl. Can you give me a tips on learning deployment of models and concentration for someone who is doing data science? Yeah, so I like to use like Fast API with Python in Python. Maybe here. Let me find it real quick. I'm gonna look this up. I'm gonna give you the exact answer. Are you ready? Projects vibe check Docker. Here we go. All right, here's the answer. So you're going to want to use this format here. It's multi-processing. Let's see, we don't care about that. It's here. It's gonna use Gunicorn, and you're gonna use specifically a Gunicorn worker class. This is what I use right here. This is what it's called Gunicorn. There you go. Gunicorn's the answer. If you have one word, Gunicorn. Gunicorn. See how. See, I want tilde / projects vibe main Fast API. There you go. Fast API. Gunicorn and Fast API. So Gunicorn plus Fast API. That's the answer. There you go. That's the answer. QA exit done exit. Okay, good. If you want it for production, that's what we use. Let's see. Recently saw the news that AI companies are increasing their pricing and token consumption. Yes, they are. A little bit more expensive, aren't they? Making AI useful and cheap is a good business idea. They're also working on that too. So it's getting faster, better, cheaper, faster, better, cheaper, faster, better, cheaper. What are your thoughts on not being able to pay for them and be locked by the price? See if you can use a local model. try a local model using Ollama and open, what is that? The open source code generator. Well, Michael. Well, welcome on in. Good to see you. Happy Thursday. Like all the GPU code is always very unsafe. Even the GPU code is just cosplaying. You're saying that cosplaying? The way to describe code is safe, and then the GPU does memory unsafe stuff. Yeah, all the time. Hey, PyTorch and TensorFlow. You want to learn? I recommend don't learn TensorFlow anymore because it's outdated. You want to go to JAX if you want the Google, or do PyTorch for Meta. There you go. Those are the ways to go. Ollama is great. You have compared it to custom code in C++ and it performs well. Oh, nice. That's very nice. Terminal style. Are you able to look at my website? Many things in maintenance. Be careful. Can I show it on stream? Can we show on stream? TensorFlow is really nice for embedded though, because TensorFlow Lite is pretty neat. Oh, I forgot about TensorFlow Lite. TensorFlow Lite. I actually remember that. I remember that coming out many years ago. Yes, but not the gallery. Okay. All right. It looks like you got some Linux boot set up there. Okay, let's type help. Don't go into the gallery. Okay. You can search Yahoo. Yahoo Claude Code CLI. Oop, I typed that wrong. Request failed. All right, you fail. Error, it didn't work. Loons, it didn't work. All right, who am I? Oh, nice. Okay, that part worked. Loons with three O's. Tech Passion Web Developer. All right, there we go. Oh, shucks. The first thing I tried, it immediately failed. Let's see if it's got the date. All right, got the date. Nice. Clear. Oh, nice. It clears. All right. Nice. All right. I like that. That's pretty neat. Although, if you're going to share this with, anyone who's you're trying, I had to throw extra steps in order to get data out of it. So I don't know if it's ideal, though it is neat. It is very neat. Loons, that was really neat. Nice website. Explanation point. That was awesome. Fantastic. I enjoyed it. It made me happy. Any resources, video to start learning PyTorch? Yes, so we're learning from pytorch.org. So this is the tutorial we're looking at right now. I'll put this in our Discord link share. Here we go. That's the tutorial we're currently looking at. Sad. There we go. Okay. Happy. Let's continue with our tutorial, guys. Hey, let's go in the Rebellion and Nike? Was that right? Wait, Nike, right? How's it going? To make AI useful, build a special harness that enforces domain-specific constraints, ensuring the model acts as a predictable utility rather than an underground generalist. Kyle, yes, 100%. You got it. That's the secret answer right there. That is the dedicated agent. You got it. Good, you want to know how I got my name? Sure. Absolutely, Rebellion Ent. How'd you get your name? Shameful but fun. You used to come and bought a Mac Mini and building out a Clawbot. Hey, there you go. Have you tried Hermes? Right, Hermes is the new one. Hermes. Oh, we had auto mod disabled this entire time. Really? I didn't even know there was one. This girl looks like Trump supporter. Hey, how's it going there? Upstate Nate. Oh, Upstate Nate. You know, I remember back in grade school, we had several students named Nate in my very small, like Nathan, very small class. I was trying to do something when you curled the website and it broke the whole thing. Oh no! I'm his aunt. Wait, really? My nephew plays for a team called the South Pittsburgh Rebellion And his mother is 22 and my birthday, 83. And I'm his aunt. Oh, that's amazing. Nice. That's a great way to name. Good name. Let me do a thumbs up. Here we go. Good name. Good name, you guys. Okay. Should I take any courses and get certification for legitimacy of a particular skill? I don't recommend certifications, such as AWS. No, they're a waste of time. I don't think that's worthwhile. I think what you really need to do is just use those systems until you actually know them. Don't bother with the certification. As someone, like, I've got my own company, and when I look at your skills, I look at your GitHub, I look at the code that you write, I look to see that you wrote it yourself, and then I look for your personality, like your what do you call it? Your collaborative skills. That's what it looked like. I like this. What's going on here? There's a kitty. Look at the kitty, you guys. Thanks. Yeah, you got a great name. That's awesome. So your collaboration skills and your collaboration style. That's what I look for. So I don't recommend certifications. You're writing a simple mini computer vision library. Oh, whoa. That sounds amazing. Cheyenne. Learned a lot from you. Waiting for convolution. All right, that's what we're going to do today. Once we get into it here. Vincord plugin called Oneco or Oneko. Oneko? Also, there's an MPC server for AWS. Yeah, there we go. Let's just use AI and MCP servers. No need to deal with anything anymore. We're just going to use AI going forward. Your Discord name? How can I connect new here? Oh, I was going there, Jay. Welcome on in, Jay. Good to see you. All right, so let's grab over here our Discord link. Copy real quick for you. Let me click this edit button. Let's see, did someone beat me to it? No, okay. So no limit, unlimited, never, generate, copy. There we go. At J, as soon as I get my cursor in the right window. There you go. Just for you, you asked for it. There you go. Hello, how's it going there, 09? Zayad, good to see you. What type of AI are you training? This is gonna be a tutorial on PyTorch. So if you want to learn PyTorch, I recommend going to pytorch.org, then going through each of the tutorials, which is what we're doing today. So we're going to do a convolutional neural network. Very simple, easy. We're going to type all this stuff out. But the code is written with the help of AI. Then you might have a hard time. That's just me, though. That's just me. I want to see that you could write code yourself so you understand what's going on. That's just me. Though, that is an old way of thinking. It really is. It's very old way of thinking. Like, very old. Because now, you just have an AI write code for you anymore. Terraform, Model Context Protocol, great. Your Identity Access Manager, that would be so amazing. I am with Amazon has always been a problem. Always get that. I always get that wrong. Okay. All right, let's get back into it, you guys. You do it every day now, so you're probably pretty good at it. Yeah, you're pretty good at it. All right, let's do some copying here. So we're going to pull in everything that we've learned so far. So this is going to be the ultimate tutorial. It's Oneko. Cool, I have Python Basics final in about 20 days. All right, there we go. You'll be able to easily, Python Basics, no problem. All right, so we need date, time, and we need summary writer. So from torch.utils, TensorBoard, utils.tensorboard, import summary writer, import summary writer. Let's make sure this runs. Success, okay. And then we need from date time, import date time. We're going to be using that for later. Are you on Ghosty and using Vim? Yes, I am, Michael. Yes. Ghosty plus tmux plus Vim. Sure am. For your first video was 14 years ago. Fantastic. Yeah, it was. Isn't that crazy? It was. Yep, got first video 14 years ago. Michael, that sounds great. You don't know why, but you don't like the syntax highlighting of PyTorch tutorials. JetBrains syntax highlighting is better. Oh, personal opinion. Yeah, there you go. That's what you do. You do the things that make you happy. That's a big part of... Are you able to share your config file? Which one? Which one? I've got, obviously, not the ZSH file or the env. We can do the vim or tmux, though. I'll do that real quick. Vi tmux. Here's my tmux config. It's very, very crazy. It's very crazy. It's a little bit much of a config there. The ghosty one? Oh. Ghosty settings? Here we go. Yeah, it's not a lot. So I just, I've got a color palette. And then I disable the title. I don't like the title. Can I zoom in on that? Here we go. So I got a bunch of pretty colors. Some key binding stuff. Font size. And I disabled the title. That's it. Geez, you did all that to yourself? Yeah. Yeah, I wanted the color palette to match my... This is Groovebox right here. This is Groovebox color palette. So we say... Groovebox color palette. There you go. Save. Close. Can you gist your tmux config? You don't want it. You don't want this tmux config. You don't want it. It's for me, it's special. And it's not, it won't make you, it will not help you, it'll hinder you. My tmux config is insane because it has very specific bindings and configurations that perfectly match GNU Screen, which was the precursor. And I still use Screen, I just use tmux more often. It maps perfectly to all the GNU Screen commands. So that way I didn't have to rememorize a new window manager. You don't want it. You don't want it. You don't. Can think just use theme Groovebox. No, there you go. Got to use the Groovebox. Okay. Let's go back to our tutorial. So we're going to create a transform, compose, two tensor, and a normalize. All right, transforms, compose, tensor, normalize. All right, let's try it out. Let me close that. Okay. The music makes a better person. Isn't it good music? It's my favorite song on the playlist. This is called Splashing Around by the Green Orbs. I really like this one. It's my favorite one. In the future, maybe everyone will use their own model, and if you don't, you're a noob. Ah, yeah, there we go. Custom model just for you. Final question, I'll leave you alone. What browser are you using? Chrome. Just using Chrome. Yeah. Easy Chrome. Right here you can see. Chrome. Right there. Yo, what's good? How's it going there, Edward? Edward, welcome on in. Good to see you. Happy Thursday. We're going to build a CNN today. Oh, it looked different on your desktop. Yeah. Yeah, it's just really easy. That's it right there. It's Chrome. Straight Chrome. Easy, easy. Ordinary Chrome. It looked like a Ninja Star? Really? I mean, it could just be because it's a small window. Yeah. I mean, the Ninja Star right here is AI, right? It's Gemini. All right. So we were, where were we at? Using Firefox just because? The new mascot. Ah, nice. All right. Transform equals transforms.compose. We're going to have a torch. Oh wait, no, transform.toTensor transform. Hey Sergio, thank you very much for becoming a member on the channel. Oh, it's so good for you. Oh, Sergio, it was unexpected. Thank you so much. My gratitudes to you. Sergio, you just got yourself a whole bunch of fun things. And my favorite, you've got some neat you've got some neat emoticons specifically related to this channel, which are the Vim, Rust, and Python. Yep, there you go, exactly. How's it going there, Stickman? Good to see you. Or, yeah, Stickman. Welcome on in. Zergio, you've got my favorite. That's so, I just like the nerdiest possible thing. The thing that makes me so happy is this Vim icon. I like this. I like the Vim emoji. See, Vim. And the Java, yeah, got JavaScript there. Steven. Oh, underscore Vim. Okay. Underscore Vim. There you go. Thank you, Zergio. Appreciate it. I like those. All right, let's hide that really quick. Wow. Zergio, thank you. Oh, Torva, you recently saw a post when Microsoft Edge can ask you to be your primary search engine, and you can ask her out. Oh, what? Really? That's unexpected. 2tensor. And we do transform dot normalize, and we do 0.5 comma 0.5. There, I think that's it. Let's try to run that, make sure we didn't make it broke. Okay, transforms, right. There we go. See, I always gotta run it. I gotta run it. Kamala, good to see you. Hey, Steven, happy morning. Well, good morning to you. It's the afternoon over here. Functional programming, Steven, with higher level functions. Ooh, yeah, I really like, that was like my favorite. That was my go-to. It's like, I'm gonna be a functional programmer going forward now. I'm gonna do a functional programming. And it was so much fun. And I still do a smidgen of it. Though I like to stick with simpler code now these days. Are you following another screen to write this? Yes, I am. Obviously. Although I kind of know what's going on for the most part, so I've done this like a few times. Oh, it's got to be a tuple. Here, I've got to tupleize this. Found an error. There you go. Tuple. Got to tuple it up. To tensor is functional. Did I do it wrong? Oh, yes, it is. Right. Because what you're doing is you're instantiating a method. You're executing a method in a class that's going to return a function. This is functional. Thank you, Neva, for mentioning this. This is functional because it returns a function. Thank you. Thank you, Neva, for the explanation. And compose is a higher level function. Compose is just an array, right? It's just gonna run these things through, right? It's just gonna run these through. Although I suppose what you could say is it's also a function, and then it just runs through all of these things, right? So you can have any number of transforms in here. Just followed you on LinkedIn. Oh, Shiva, thank you, Shavim. Can I ask you bluntly for some mentoring? Sure. Join us on Discord or on LinkedIn too. Steven doing a higher level function on stream. Apparently, Compose takes functions as arguments. That's a good point. That's a good point. Let's make sure it still runs. All right, we're looking good. Okay, good. Okay, so now we need to create our training set and our validation set. Training set and then our loaders. So we get our sets and our loaders. So let's do this. Torch Vision datasets, fashion MNIST. Training set. It's going to be Torch Vision dot datasets dot is it called fashion MNIST? Are we doing fashion MNIST? Oh yeah, we are. Okay. Fashion MNIST. Which means higher level. The fact is simple. It doesn't change that. That's a good point. That is a good point. It's still functional. So yeah, occasionally functional programming is simpler. Sometimes it is. I like my lambdas. That's my favorite. My favorite right here. I like my lambdas. Kamala, it's good to hear your name coming out of my mouth. You have an excellent memory. It's good to see you again. It's good to see you. Let's see. What did we need? We need, what was in here? All right, so I guess, sure. Data, I guess, for the directory. Oh, that's where we're going to store it. Train equals true, and what, transform. Okay, we're going to pass in the download true. Okay. Transform equals transform. and the download equals true. Okay, I believe that takes care of that. This will be validation set. So this is training and testing. So train, this should be false. I think everything else is the same, right? Yeah. Okay. This is great, you guys. All right, so now we're going to create our data loaders. Torch util data.data loader. That's a lot of stuff to have to deal with there. Let's do training loader. Torch.utils.data.data loader. Data loader. And we're gonna have the training set, I believe. Batch size and shuffle. Okay. Batch size equals 4 and shuffle true. Let me copy and paste this for our validation loader. Validation. And then we need this to be our validation set. The rest is the same. We don't need a shuffle though, false. I don't think we need to shuffle that, right? No shuffling on that? No shuffling? Yep, shuffle false. I knew it! When are you breaking out your data set utilization? Oh, okay, there it is. Well, not quite. Yeah, I mean, yeah. So this is, I believe it's like 20%. This is 80%. Oh, right here. 20%, 80% of the data. If that makes sense, if that's what you're asking for. What's the batch size? The batch size is 4, which means we're going to use 4 samples of the data. It's the weekend for you. Oh, sorry, missed your message over there, Loons. Just look at a new mascot. Also, there is a new free VPN. Hello, please. It's the weekend for you. Loons. Oh, something over here on Discord, maybe? Woo, we got some people in Discord. Thanks, welcome on in, you guys. What's that on link share? Cat follows mouse, real. Okay. Let's get back into it. Where is that determined? Oh, this is predetermined. This is a toy data set. This toy data set. If you want, you can change it though. So I think you can say training set dot data dot features or something like that. Let me double check here. Python import torch. And then we're going to say import torch vision. And then I'm going to copy this real quick. Transforms not defined. That's fine. So what I can do is define it. We don't need to define it. Here, I'm just going to change the name. We don't need a transform for this situation. There we go. We say training set. And then I believe there's something about data in here somewhere. Data. Yep, data right there. Okay. Dot data. And then what's in here? What is all this? There's a lot in here. Oh wait, that's a little bit more than I was expecting. How do we deal with this? So validation should be around 10% typically. Training 50. Steven transforming. Yep, got those transformers going. Then the rest you actually test. So 50, 40, 10. Oh, yeah, okay, got it. All right. You put the link in link share? Okay, sounds good. We'll check a quick over here on link share. Oh, hey. We got some, Kyle. Oh, wait, so Firefox, what is this? Meet Kit, your companion for a new era. Oh, that's right. I remember this.
The internet is changing, and it needs Firefox more than ever. Introducing Kit, our crusader, your companion, giving you privacy, choice, control, so you can browse with peace of mind and roam without being tracked, here, there, everywhere. Wherever curiosity calls. More fire, more fox.
Definitely going to check them out.
See what we did there? Firefox, the internet as it should be.
Nice. Yeah, that's a new good mascot. I remember that. I remember Kit. Yeah, that came out last year, right? Or did it come out earlier this year? All right, we're going to take a little break from our code here, and we're going to go into some reactions on some videos. Thank you, Cal, for posting those. So removing 50% of the training data is just too much. I think so too, because it needs to learn. It's got to learn. You got to teach it. 50% is a big amount. Yeah. I typically do 80-20. I do 80-20. Okay. Let's jump into some reactions, you guys. We got 1, 2, 3. We got 3 videos. Thank you, Kyle, for posting this.
So this has to be one of the coolest use cases for AI. Part 1. A startup put AI-powered GPS collars on cows that can track their location and then steer an entire herd by building virtual fences from your phone. First, let me paint the problem. Currently, there are 29 million beef cows in the US, and for a really long time, the only way to control where these cows go is by building fences. So if you wanted to rotate your grazing area, you gotta build more fences and then move all those cows over. But with this new approach, each cow wears a solar-powered GPS collar that talks to towers on that property over LoRaWAN. Basically a remote sensor network. The farmer draws a boundary on their phone and the collar enforces it. And the collar has 2 directional speakers, one per each ear. As a cow gets closer to the virtual boundary, the system calculates the angle of approach and then sends a buzzing tone into the ear on the side it needs to turn away from. And the cow instinctively turns towards the sound. That's the primary cue, and within a few days, most of the cows automatically learn those boundaries. But underneath all that is where the real AI lives. Every collar is sending back data about that cow to a machine learning algorithm, which they call the cowgorithm. Crazy name. But what it does is it continuously updates a behavioral profile based on that cow's historical response patterns. You can think of it as a reinforcement learning loop. The cow emits a cue, observes the cow's response, and then adjusts the parameters for next time. Because cows have personalities. Some are going to comply, and others are going to push the boundaries and say, yeah, screw that buzzing noise. So for those non-compliant cows, the secondary cue is a mild electrical pulse. It maxes out at about 0.18
alright, now we're
joules
getting
to make the cow
into
stay
pain.
within those virtual fences. And while all of that's happening, the same data stream is also looking out for early signs of illness just from looking at how the cow is chewing. It can also flag reproductive cycles based on its movement patterns, and also track how the grass is recovering across different areas of the farm. And the rancher sees none of that complexity. They just tap a button and 600 cows start walking to the milking shed at 4:30 in the morning, for example. So your entire herd becomes almost like a live, continuously learning sensor network. This is really innovative, and who knows, with the way AI is going, maybe we'll be wearing this in the next 30 years. Follow and I'll keep you posted.
Yeah, it is a bit complicated. I mean, how about we do this? I've got an idea. Have you guys heard about this? You might have heard about this technology. It's called a fence.
So
have you heard of this technology? Have you used it before? It's a pretty neat technology. It works pretty well. It's called a fence. I am into technology and I think this is great. I just think that there's something more practical that most farmers will have a good time understanding how to implement. What's a fence? Someone probably. I know, right? Jinlu? It's good to see you, Jinlu. When automation goes too far, all right, there's a bit too much. It's a bit too much. At least they're trying, right? I give them props for trying. The things that actually hurt cows. Exactly. Never heard of it. You never heard of it. You're free on Discord. Nice. All right, let's go to the next one.
In some of the more unhinged geopolitical tech drama of the day, China just told Meta to give back a $2 billion AI company. This is Silicon Valley versus the CCP. So for context, Meta bought a Chinese AI startup for $2 billion. China told them to give it back. There was no negotiation.
This is like the Maroon
deal,
one?
Just a one-line
What was it called?
statement from China's top economic planner. Unwind the deal. The startup in question is Manus, the AI agent that broke the internet last year. It was founded in Beijing by Chinese engineers. It relocated to Singapore. It was scooped up by Zuck in under 2 weeks. 100 Manus employees have already moved into Meta's offices. The technology is already being integrated, and now China says, actually, that's ours, give it back. A little bit of context. Manus launched in March 2025, and it went immediately viral. Invitation codes were selling for $15,000. 1 million people joined the waitlist overnight. The product was an autonomous AI agent. It does more than answer questions. It does things like book flights, writes code, builds web apps, analyzes stock trades. The critics called it just a wrapper stitching together Anthropic's Claude and Alibaba's model with no real technology underneath. The hype cooled, but the business did not. It stayed hot, $125 million in annual revenue, 2 million users on the wait list. And as we know, Mark Zuckerberg likes new shiny things. He wanted in. The founders had incorporated in Beijing back in 2022 as Butterfly Effect. Cool name. Mid-2025, they moved the company to Singapore so that they could use Western AI models and raise international capital. Chinese social media was furious. One post on Weibo that went viral said that Manus abandoned its home country after leveraging cheap and quality Chinese engineers. Betrayal. Beijing reviewed the move at the time and said that it was fine. No core technology was under export controls. Capabilities could all be replicated. Nothing to see here. Or so we thought. And then in December, Meta bought them for $2 billion. The deal closed in under 2 weeks from first contact. It was basically just one DocuSign and done. Meta planned to fold Manus's agent technology directly into Meta AI. The CEO would report to Meta's COO. 100 engineers started moving into Meta's offices. It looked like the rare cross-border AI deal that actually worked. We spoke too soon. China's Ministry of Commerce started a review in January. Then Xi Jinping's National Security Commission stepped in, called the deal, quote, conspiratorial, whatever that is in Chinese, an attempt to hollow out China's technology base. The officials who had originally cleared the Singapore relocation came under pressure to correct their earlier judgment. They said, we were wrong. This is actually not cool at all. In March, the two co-founders
They made the call, though. They made the call. They're like, it's fine. You can do it.
From leaving the country. Today, the NDRC, which is the National Development and Reform Commission in China, top-level agency that functions as its main macroeconomic planner and regulator, this agency issued a one-line order aimed to square.
Okay, it just ended. Her video is too long. So that was a long video. For China, here's the part that I think is weird. They already said it was okay. They're like, okay, we'll do it. It's approved. And they're like, they changed their mind later. How is that fair? How is that fair? Zuckerberg hollowed out China's tech. Is that, well, we're trying to, got to keep that tech going. You guys got to keep that tech going. I think that it was bought fair and square. It was given permission. And now that the fact that they want that back, I mean, say yes, but now it's a different time. They've already ingested it. It's going to be a different price if they really want it back. How's it going there, Busy Slim? Welcome on in. Good to see you. Based on deception. Exactly. There's some deception in there. I mean, it's not a conspiracy. It's just an outright acquisition. Something that happens all the time. Why does it have to be a conspiracy? The shocks are pretty standard. Yeah. Oh, the electrical fence. Yeah, I forgot about that. Yeah, the electric fence. Busy Slim. Yo, dude, hope you're well. Hope you're well too, Busy Slim. We're just doing a quick little video reviews here. Kyle posted some links here. Not worky giveaway. Now at worky. Want it back. Exactly, loans. Uh-huh. They're like, oh, wait, we changed our mind. Well, it's too late now. It's too late. It's ordinary business practice. All right, let's go to the next one. And then we're going to jump back into our PyTorch here. It's late here. What time is it there for you? It is 2:05 p.m. See, 2:05 p.m. Afternoon. The cows will learn the shocking so it pays off in the long run. Yeah, they will. They'll learn to avoid. Whoa, Jin Lu. Oh, you got a new song? Bogo Sir. Oh, no, it's not a song. It's we'll have to. All right, let's check this out real quick, and then we'll jump up to Kyle's last video. What is BOGO sort? Oh, it's a live. Oh, wait. Do they have details? It's a live stream. Stream ends when it's sorted. 12 hours ago. Awesome moderate. No, what is a BOGO sort? Shuffle and check. Oh, so it's RNG. So it's a random. So what are the chances? How many elements are there? 24, 25 elements? Yeah, there's 25 elements, it seems. So what are the probabilities? A lot, because it needs to be all in the right order. So it's going to be live for a little while. Oh, 24? 24? I thought I saw 25. I see 25 in here. I guess it's 1 to 25, right? 1, 2, 3. I see 25. Do I see more? Here, let's zoom in on that a little bit. Yeah, 25 right there. I saw 25. Basically zero chance of happening. Yeah, basically, exactly. It's good. It'll never happen. That's crazy. I need to react on that one. Okay, last video, guys.
This has to be one of the greatest ideas in computer science, or probably one of the stupidest ones. Meta just dropped a research paper questioning what if we replaced every part of the computer with an AI model. So the compute, the memory, the operating system, things with decades of engineering, let's replace all of that with an AI model. Now, stick with me. I'm not talking about an AI that runs on a computer. I'm talking about an AI that is the computer. They called it a neural computer, and they actually built a prototype for it. Meta trained it on over 800,000 real terminal screen recordings, basically just watching humans use computers for over 1,000 hours. The model learned to predict and simulate future screen states from a single starting frame and a text prompt. So technically there is no operating system or a processor that's routing instructions. It's just the model guessing what comes next. And along with that, they also trained it on full desktop interactions. This includes mouse clicks and scrolling. So this thing is simulating an entire desktop, and your screen gets rendered frame by a model. And once they have this running, they put it to the test. Let's start by asking basic math questions. It got it right about 4% of the time. But when they rewrote the prompts with better instructions, it jumped to 83%, which is great, but it's actually telling you everything you need to know. It's not computing, it's pattern matching what computing is supposed to look like. So you have some folks on Reddit and X saying if this gets the proper attention, this could be the biggest shift in computing since, I don't know, 1940s? While you have others saying this is the dumbest thing ever. So is this the future of computers, or is it just another metaverse?
We got the Zuckerberg up there. All right, so let's think about that for a second. Let me jump back. No, wait. So this was researchers at Meta are trying to mimic computer actions with AI. This is where they're saying we're going to record all of our employees' computer clicks, typing, and interactions, right? So they're taking all the keyboards, all the keyboard action here, and all the mouse action. Doing it, dude. How's it going? Welcome on in. Sounded like that is a AI generated. Was it? Well, I mean, it's gonna be, right? Maybe. Yeah. Let me read the description. Yeah. So researchers at Meta are trying to mimic computer actions with AI. That is weird because you need an input about what the intent or goal is going to be, right? If you just have a screen and you don't have a direction or some sort of goal for the AI to achieve, it's not going to know what to do. It's just going to be RNG. It's going to be random number generator. There's nothing you can do. We had this for a Unix terminal already. This is a very old paper. Oh, is it? No way. All right. Let's get back to our tutorial, you guys. Let's get back to coding. So this is what we'll wrap up for the day here. I know it's fairly a practical measure. It's much more compute and less accurate. It's at least they're trying something. I mean, I can at least give credit for an endeavor that is a very hard problem to solve, right? That is a very hard problem to solve. So maybe they've got something that we don't know about yet. It's a scapegoat. Meta recording all the mouse and keyboard actions for their employees. No opt out. No, you got to do it. And they're going to track to see if you're being productive. And if you're not productive, then you'll be on the list. And if you get on the list, that means, made the math. Chance to get the BOGO store right now is impossible. Whoa. Loons. Okay. Wow. That's crazy. There isn't any actual point. It seems like it is. It's an excuse. It's an excuse to track. Are you guys doing what you say you're doing? We're gonna find out, aren't we? It feels ridiculously unoriginal and don't show any interesting architecture or change. It seems like it. It seems like it. Okay, so let's get our classes here. I'm just gonna copy. I'm gonna copy and paste this because I don't want to do. I don't want to type that in. Oh wait, where were we here? Whatever. We'll won't bother with that. Okay. Paste class labels. There we go. See here. Why are you doing coding without any AI tools these days? Oh, hey, how's it going there, Pandu? Welcome on in. Good to see you, Pandu Adventure, you guys. So you know what? We are teaching ourselves PyTorch, right? So in order to do that, I think the best way is to hand code it. Now that just could be because I'm old, right? I'm old and I have a design that I'm used to, learning new things with actually getting hands-on experience. So that's what we're doing here. That's exactly what we're doing. I want to learn things, you guys. So otherwise I would be using AI. I use AI all the time to write code. Or, well, I use the AI to write the code for me, is a better way to say it. All the time, every day, every single day. I've got Claude Code terminals open on and off. They're just everywhere. They're all over. All right, training set. Okay, let's do this. So print out. You don't have to use format anymore. This is old. How old is this? 2021, wow. All right, let's do it the right way. How do you learn new languages like that though? Like when you struggle, look at the documentation. Yeah, yep, you peek through, you're like just smidge of the documentation there. Yeah, so what you need to do is you need to set out, you need to have a goal or objective, and then you need to sort of write out your path to achieve that objective and do that with code. And if you don't know how to do it, then you probably go to Stack Overflow or Google and say, how do I do this? And then you type it in from there. That struggle is really important for teaching yourself. It was like for a minute, you kind of not interested in doing AI work anymore. Oh, really? Uh-oh. You lost your passion. Don't worry, it comes back, it comes back. So let's do print, fstring, training set size. This will be len of training set. Training. There we go. And then validation set size. Let's see if that runs. Archive. Okay, so let's do some math on that. So total equals let's see, validation set plus total size, and then we want, let's say, here, then we can do division. We can do some division here. Thank for the hearts, you guys. Appreciate it. Thanks so much. Good to have you here. Let's keep going. We're coding now. We're coding. We're like deep into coding. All right, we're doing focus mode. When you like your YouTube live, there is a light bulb. Is there really? Loons, I have no idea. All right, you guys, focus mode, focus. Let's lock in. Let's see. And then that is, let's do a percent. We'll do percent len training size, and then we do, there we go, divided by total, right? And we do multiply that by 100. And we'll do the same for validation set here. We'll just like do a little quick, easy, a little smidgen easy. There we go. Looks good. There we go. Okay. Yeah, multiple papers on how to change tokenizers and dedicated lexers. What are you guys talking about? Loons deleted blocked term. I see what you're doing. That's neat. I didn't know you could do that. Let's see. Oh, wait. Why can't I do that? Oh. Oh. Really? Really? Okay, fine. I messed that up. Here we go. There we go. It's still an int. What? I thought I fixed that. Let's see here. Yeah, Lynn and Lynn. There we go. Okay. And then there's a way to, like, say colon.2f. Can we do that? Did that do what I wanted? So it's 85 and 15 for you guys, whoever wanted to know what the training and validation split is. So 85 and 15. See, F2? No, it's got to be 2F, right? It's gonna be an error. 1F. Oh, can I do? Yeah. Whatever. We got enough. Well, what I'll do is I'll round up. I've got an idea. Nice. There we go. Percentage. All right, whatever. Okay, happy, satisfied. Let's continue. All right, so what we need to do now is we've already loaded the data, so I should have a data dir, right? There's the data, fashion MNIST, good to go right there. Okay. So now let's visualize the data. We're gonna follow through on the tutorial. We're not gonna skip any steps. Added another scary word. Oh, thank you. Thank you for adding another scary word. So we're gonna do matplotlib numpy. PLT, import matplotlib dot py plt, or plot as plt, import numpy as np. Light mode? What about light mode? All right. Locking in, you guys. All right, so we're going to do an image show, which is going to add an image to the grid, and then we need to run image show, and then we need plot.show. This is another bug that I know is existing here. This is a bug right here. They just copied and pasted this. This is the same bug as before. We need to report this bug. There's a bug in here. Do you guys know where the bug is? Do you guys know where the bug is? I'm kind of curious. All right, here we go. Wait. Okay. Let's see. Where is the bug in the tutorial? Tutorial? Question mark. How do I give you the answer? Let's see. Let's say the iterator. Next iterator. Let's say we're gonna say numpy use. Let's add another option. This is gonna be hard. This is gonna be a hard one. It's gonna be a hard one for you guys. I'm gonna create a poll real quick to see if you guys can figure it out. Where's the bug? Also, it's not like it's a big bug. It's just we'll figure out what makes it good here. Let's see here. 1 second. I see a little bit of a degradation in I'm dropping frames right now. I see I'm dropping frames. 1 second. Are we still dropping frames? Yeah. Getting connected here, you guys. 1 second. Oh, we're back. We're back to normal. Still learning? Okay. I want this. Uh-oh. Well, that's not going to work very well. Oh, well. Okay, we're just going to work through it. We're going to work through it. We're going to pretend everything's fine. Let's see here. Let me go through and make sure this is on. Okay. We're getting connected back up here, you guys. Okay. All right. NumPy, and then let's see here. Where else are we? Then is it going to be plt.show, or is it the join? All right, this will be tough. This will be a tricky one, you guys. Let's see here. Sorry, stream is fine for me. Did see you drop frames though. Okay, good. Good to hear. Good to hear. Oh, are we connected? Let me see here. Okay, just in case. Just in case. I've got it ready to go. I've got the 5G up. I've got the 5G up. Okay. All right, you guys, let's get back into it. We're gonna do this part. All right, so we're gonna write this function here. If one channel. Do we need that? One channel true. If we're just assuming that it is going to be one channel, let's not even bother with the if statement. Okay. Def AMG show. So we're gonna display the picture. IMG, just IMG. That's it. And then we're gonna say unnormalize. Oh, that's neat. I didn't know you could do that. Look at that. That's like a really neat little trick right there. Okay. IMG equals IMG. So was it divided by 2 plus 0.5. Okay. And then this is weird though. It's weird. NP img. Okay. Let's see, yeah. img.num. Oh, to numpy. Oh, I see what's going on. Okay. img.numpy. So this is going to convert our tensor to a numpy into a numpy. NP img. Let's make sure this still works. Okay. All right. You have a 1+9? Yes. Very good for spotting tiny details. You are, Loons. You figured it out. Very nice. You figured it out, Loons. So we're going to do... I don't want to grayscale it. I just want to show it regular. So plt.showImage. That's it? That's all we have to do? Look how, like, advanced this looks, and you don't need to do any of that. So this is going to be plt.showImg, right? Or IAmShow, right? IAmShow, and then MP. That's it. Right there. That should do it. That should do it. The Wi-Fi. Oh, yeah. The Wi-Fi name. That's it. Yeah. All right. There you go. You figured it out. You figured it out. Are we connected? Yes, we are. Okay. Just in case. Got ready to go. Ready to go. So, you know what? I'm looking at the poll right now. I think you guys figured it out. I think you figured it out. The majority of you, I'm looking at the winner, the current winner. You think you figured it out. Good job, you guys. Very good job. All right, let's show one of those images. We're going to get a data loader, and we're going to grab a batch. Okay, data iter equals iter. And we're going to load in our data loader. There we go. We're going to say images, comma, labels equals next data iter. Data iter, please. Thank you. And then we're going to grab all those and then throw those into img show images. Is that it? Is that all we got to do? I think that's it. Oh, wait, no, we got to do one more thing. We got to do one more thing. So I'm going to try this. I'm going to say 0. And let's try running it. Okay, we got a problem here. We got a problem. Invalid shape. Is that because of our transform? No, it's because of this. Let's hide that for a second. Okay, invalid shape. What did it want? What is it looking for? What's about IM show? It's just fine. We're gonna find out. We're gonna find out in a second. You're gonna see, Neva. You're gonna see. You're gonna find out. All right, invalid shape. That's a perfectly fine shape. Do we need to change the view or something? View -1. Can we do that? 784. Oh. 28, 28. What if we do unsqueeze? How do we eliminate? Oh, I know what we're doing here. 0 there. How about that? How about that? Perfect. Okay. So let's try that here. So this show one image, just one image. Yep. It needs to be a 28. Yeah, but we got it. We figured it out. Though I would like to know, is there a PyTorch way, like squeeze or unsqueeze, right? Let's try it. Let's do dot unsqueeze, SQUEEZE. We'll go 1. Can we do that? Or is it called squeeze? No, it's squeeze. Okay. Squeeze. Squeeze 1. No? Squeeze 0. There we go. Okay. None? Oh, yeah. Okay. So there's a couple ways to do it. There's a couple ways. We could just do 0, 0 like this, which is, I think, a little bit more shorthand, though. I like the squeeze there. Or just the index at. Oh, let's try that. So we could do, did you say colon, colon, comma, 0? Does that work? No, that was weird. Like squeeze and unsqueeze are that hard to do without mentioning it by name. Yeah, I see what you mean there. I see what you mean. This doesn't quite do the trick though. Gotta go by. All right, Kyle. It was good to see you. Thank you for hanging out with us today. We'll see you tomorrow, or whenever you choose to come back. It was good to have you here. Well, it's been great, you guys. Gotta go to sleep. All right, Torva, sounds good. It's good to have you guys here. Steven will probably be able to push the ticket feature this week or next week. Have some more time since there's no uni due and 2 public holidays. Hey, that sounds great. 0 and 0. Okay, so let's do, you said 0, oh, 0, comma, 0, and then colon. Like that? 0, comma, 0, comma, colon. All right, let's try that. Nice. Okay. So now, Neva, now that you see here, it's good to have you guys here. Thank you for joining in. We'll see you guys next time. See y'all. It's been a pleasure. Nice. Yeah, just a colon. So do you see where the problem is now? You see, so we're running the code. You know what's not happening? We're not actually seeing anything on the screen. Right? Right there. See the tutorial. We're following the tutorial. We sure are. This, nothing shows on the screen. It's just not showing. There, exactly. plt.show. You figured it out. You figured it out. Boom, right there. That was on purpose? In the tutorial? Was it on purpose? I don't know about that. I feel like someone who wouldn't know, they're going to run into a problem. Because see, there's no show. It's just like, that won't work. They won't see that. On purpose. You think so? I mean, Sergio, I don't think I've seen you use... Oh, slices? Oh, like a smiley face? Yeah, the good old smiley face. I mean, you could also do this, right? I think this will work too, right? Well, maybe not. Yeah, that works too. So you could do 0, 0. It might work in Jupyter, actually. Oh, got it. Okay, so we're running it from a terminal window, right? And so we get the short stick. We get the short stick. Let's do a grid. Let's do a grid really quick. Torch utils make grid. So img grid equals torch utils dot. Is it torch vision? Yeah, torch vision. Torch vision utils make grid images, and then we should just be able to simply pass in images directly like this. Let's try that. I should be fine. You just use a lot of parentheses and brackets, so not that much of the time. Oh, with the colon? Yeah, gotcha. The colon was just for show. Was it? Never. Are you sure? Was it just a... Are you sure about that? Just for show? How many times can this work here? So, can you do a comma, colon, like that? Would that work? No, it doesn't like that. Too many indices. Okay. The colon's just for show, you guys. Just for show. Kamala late here. Gotta go. All right. Good to see you, Kamala. We'll catch you guys next time. Said it was for show. Yeah. Nice. Good to see you. You can do 2. Oh, got it. The point is to show how many dimensions. Oh. Yeah, good point. Okay, so there are 3 dimensions and you're bringing it down to 2. So we could do another one. Yeah, we sure can. Look what I see here. I see a picture. All right. So just for fancy, if you want to keep your slices and make them like this, you can do that. You can make them like this if you want to. A little bit of extra syntax here. Just a smidgen of extra syntax. So thanks, guys. Sergio, thank you. All right, let's see here. Invalid shape 3, 32, 20. This is odd. Oh, actually, that's fine. It's just that it's supposed to be merging it. It's supposed to merge it, you guys. One channel. Na. Image equals mean. What if we did this? Do we need to do that there? Is that something we need to do? Okay. We just needed to average it out. Okay. There you go. Now you're seeing it. There you go. Hey, Kevin McAllister. Good to see you. Oh, nice music. Yeah. It's important because also the assert that you have in the end, 2D. It's got to be 2D, right? It's going to be a 2D. By the way, Stephen, for a map plot, pretty sure that they do color in the last, not the first dimension. Oh, so it's got to be switched. Gotcha. Okay. I was working on the fashion image too. Really? Wait, you're working on it? So this was an easy day today. Today we were doing CNN full tutorial, top to bottom, everything we've learned. So it's like a full review of everything that we've learned so far. You're starting to work though? The PyTorch tutorials too? Hey, nice! All right. Let's learn PyTorch together. We'll become PyTorch experts, you guys. So we just saw our data. They're showing it in grayscale because they're using a grayscale CMap. And I just want to see the colors. I think the colors are pretty interesting. All right, let's get through the model here. The model is really straightforward. We've done this multiple times. This will be our garment classifier, you guys. This will be a garment classifier. Okay. So we're going to say our, let's see, def, how do you spell garment? G-A-R-M-E-T with one T? Classifier. There is one thing that is very important for me when I'm going to use a product, is the website, the mascot, the marketing. PubNub is a good place with the site and the marketing, with the music, but no mascot. Oh, you're right. We don't have one. That was like in the early days. It's like, do we need a mascot? Like, do we need one? It was a big question. It was a big question. And I'm like, well, does IBM have a mascot? What about like, I guess Facebook has a face, right? The Meta has an emblem, like the infinity symbol. So, I mean, you're right though. We're missing it. We're missing one. Def class. So this will be torch dot module. I think it's torch dot module, right? Then we do def init self input. Let me say super garment self dot init. Right, did we get that right order? Yes, we did. Okay. Torch module. PubNub can have Steven in the chibi style of mascot. I didn't even think of that. We could do that. Chibi style, you guys. Kevin, you've got an idea there. That could be a thing that we might do. All right, let's make sure that we did this correctly. No errors. Torch.init, isn't that what we did? Yeah, torch.init.module. Right here. That seems fine. This is class. That's why. Okay. You think Gemini's Nano Banana could make one? Yeah, it could. Yeah, it could. Yes, indeed. All right, so we're going to do a simple ConvNet 1, 2, and then some linear layers. And 165, 2x2 pool. And then so 6 filters, kernel size 5, 16 filters, kernel size 5. So let's do conv1, conv2, okay. So we're going to say self.conv1 equals torch.nn.conv2d. Is that right? Yeah, conv2d. 1, 6, 5. We'll do a conv2. And this will be a 16, 6. What is our same kernel size, right? Yeah. And we're going to do a pool. Self.pool equals torch.nn. See. We max pool. 2 dimensions. 2x2. Okay. So we've got multiple pools here. IBM doesn't have an official mascot. Their closest thing is the beef from designer Paul Rand's famous IBM. Oh, really? I didn't even know that. Where the B in IBM is represented as a bee, like a flying bee. They're better known simply as the nickname Big Blue. Ah, yes. Good. I forgot about that, Loons. I forgot. All right, see how. All right, is that still running? Okay, we're good to go. Okay. Model equals garment. Let's make sure that we can superize this. Okay. Missing one parameter. Oh, the init doesn't have anything. That's the forward. Def forward self inputs. There we go. Pass. Let's make sure that runs. Okay. Looking good now. So we're going to need 3 linear layers. Self len1 equals torch.nn.linear. And this is going to be the size of, let's see, our input will be, can you hear the music too? Yeah. Uh-huh. You get a little bit of music there. What do you call it? Old MacDonald had a farm. I've got the music on this side. Let's see here. I want 16. Okay, so 16 filters by 4 by 4. Okay. 16 filters. So this is 16 filters times 4 times 4, which I think are our channels. And then the output's going to be 120. So that's the output dimension. See, 2 and 3. So it'll be 120, 120. And this will be 120 and classes, which is going to be 10, right? There's 10 classes here. I suppose if we're gonna try to follow the tutorial this time. We're not gonna mess around with it too much. All right, so we've got all of our layers defined. Now let's run those through the forward pass. Out equals, see, conv1. Inputs. Return out. Okay. And then I wanna test it here. All right, see, print to see out equals model. Then we're gonna go images. Then we're going to say print out. Let's make sure that we did this right. We should see, that is correct. I believe this is correct. Is this correct? Yes, that is correct. Okay. Okay. They want us to have a ReLU. I'm going to use a GelU. And then we want to pool it. Okay. Let's do, see, torch. Well, what we could do is we can have an activator here. Self.GelU equals torch.nn.gel. See, how do you say that? Let's find out. Let's see what it actually is. Python import torch. Torch.nn. Let's see, dir. Here it is. Gel. Is it all caps like that? Where's the? So that's. Let's try this. ReLU like that. See, I'll just call this. Let's call it gel. And then I want to say, self.GelU. Let's make sure this works. Okay. Then we will test this out here. And it worked. That did the trick. That's ReLU. That's straight up ReLU. Okay, so I want GelU now. Can I just say GelU like that? Is that better? No, it doesn't like that. There isn't one. I guess it's with a capital E there. I'm good, thank you. C-E, all right. I saw that in the dir. And there we go. Okay, we're looking good now. All right, we're on the right track. We're on the right track. Okay. So then we're going to do a pool. Do we activate first or do the pool first? No, we do the pool second. Self.pool. And there we go. Perfect. Let's run that again. Are we looking good? I think so. Okay. Now, let's continue onward. So let's be out. We're going to the next ComNet to... I think that's it right there. Easy. Yep, there we go. And then we need to do our linear layer, and we need to set a view on that. Self.linear1 lin1 self dot see out, but we need to activate this as well, and this needs to be a dot view -1, and this needs to be, is it 16 by 4 by 4? I think something like that. But before we do this, let's get the shape so we understand what that looks like. Okay, so it is 16 by 4 by 4. Perfect. Okay. So we need to output that as a different view. I just want to see what the view looks like afterwards. So this should be a vector. This should be a vector now. Okay. So yes, it's a vector with a batch of 4. That is size 256. It's a 256 vector. Okay, perfect. So we got 4 vectors because it's the batch size, right? It's the batch size. And then I want... We're going to... linear output. Yep, there we go. There we go. And I think we need to do a self.GLU. 3, 3. And then the final output is going to just be a linear out, right? So now we should see, what we should see now is a 4 by 10 shape. That's what we should see. The output now should be a 4 by 10. Right here. Or a complete failure. Let's see. Is invalid for input size of 480. So where are we wrong here? Oh. I know what the problem was. We don't need to reshape it every time. It was really easy. That was a really easy problem. Okay, now it should work, right? There we go. 4 by 10. Perfect. It's exactly what I was looking for. Nice. All right. So let's keep going, you guys. Now that we've got our model working and we've proved that it's got the output, we will do one last part here and just get our activations ready. We already have our dummy data. Oh, so this will do a quick little loss. Neat. Oh, that's kind of neat. You know, we don't need, we already have that. We don't even need that. So we already got our data here. We got our data. So let's grab our loss function equals torch dot, we're doing cross entropy loss, right? And then we can test it. Loss equals loss function. Then we will go images. No. Out, comma, labels, like that. Print loss. See what that looks like. All right, there we go. The loss is 2.3, looking good. All right, that's a good start. That's a good start. So we are basically halfway through, which is very good. We're at halfway point. What we want to do is, I would say, all right, let's type up our optimizer really quick, and then this will put us in a good spot for tomorrow. Optim equals torch.optimize dot stochastic gradient descent. Then we say model dot parameters, and we also say LR equals 0.001. Let's see if that works. Get our optimizer ready for tomorrow. Did I typed this wrong here? Optim. How about that? There we go. Easy, easy, easy. All right, you guys, thank you so much for joining today. We'll be back tomorrow with the second part of our full walkthrough on creating an end-to-end PyTorch training model, which includes all the data, all the steps, everything you need to sort of take a look at what the data is, and then we'll be ready to go. We'll be ready to go. That's the plan. Good to have you guys here. We'll be back tomorrow. Thank you so much for joining today, and we'll do more to become a PyTorch expert. It was a lot of fun. Thank you guys. Had a lot of fun today. We'll see you tomorrow. Thank you, Sergio. Thank you. It was good to have you here. Thank you very much. We'll have you on the tomorrow, which is Friday, which, hey, we're on the weekend. We're getting started with the weekend. Good to see you guys. Bye, everybody. Have a good one. See you tomorrow.